Here we're going to begin looking at quadratic equations. So what is a quadratic equation, first of all? A quadratic equation is an equation, I should say a quadratic equation is an equation that may be written in the form, here's the form, ax squared plus bx plus c equals 0. So first of all, you have a variable. Usually our variable is x, but sometimes it can be y or something else. So you have a variable, so here's the variable. And then you're going to have real numbers called coefficients. A, B, and actually C is called a constant. So A and B are actually called the coefficients, and C is a constant. So you get these real numbers A, B, and C. And you have to also remember that the leading term, the square term, has a non-zero constant. So you actually have to have a square term, right? If A were equal to 0, you wouldn't have a square term there. So basically a quadratic equation is an equation where you have a polynomial with the largest power being 2. Largest power is 2. So it's an equation where the largest power is 2, basically. So all the time your quadratic equations won't be in this form, but you're always able to write them in this form. Now let's see. Just do solving quadratic equations. That's what we're about today. We're just going to jump straight to some exercises. Solve the equation. Number 1. So what do we have? We have x squared minus 81. So this is a quadratic equation. If you wanted to write it in the form ax squared plus bx plus c equals 0, you could write this as 1 x squared plus 0 x plus negative 81 equals 0, right? That's technically the same thing. So here you could see that a is 1. It's the number here in front. B is 0. It's the number here. So originally you didn't see just an x term in the equation, but you can invent an x term and just call it 0x. And C you could call like negative 81. Yeah. A, B, and C. In any case, we want to solve this. So how would you solve this? Well, I mean, this is practically a power equation as well, right? We just did power equations in the previous video, so what you could do, if you wanted to solve this, easy way is just add 81 to both sides. So you get it in power equation form. You get x squared, 81 negative 81 cancel, equals 0 plus 81, 81. So x squared equals 81. X to a power equals a number. This is an even power here. So if I have an even power here, I'm just going to drop it. I'm going to write down the x. I'm going to write an equal sign. I'm going to put, when it's even, plus minus, in this case, the square root of 81. So, change colors on me. So we're going to have x equals plus minus, square root of 81 is 9, plus minus 9. So sometimes your quadratic equations will turn out to be power equations, and that'll be the case when you don't have an x term in the middle. So here we didn't have an x term in the middle. So anytime you don't have an x term in the middle with a quadratic equation, it'll turn out to be a power equation, so you can just solve it like a power equation. Okay. But what happens when we have an x term in the middle? Let's say we have something such as this, x squared plus 3x plus 2. X squared plus 3x plus 2 equals 0. So this one has an x term in the middle. So it's not going to be a power equation type. So to solve this, we're going to use some factoring. So what I'm going to do, I'm going to factor the left-hand side. So I have 0 on the right-hand side. Once I have 0 on the right-hand side, I'm going to factor the left-hand side. I'm going to factor that. I'm going to make 2 pairs of parentheses. This is all equal to 0, remember. I'm going to ask the question, okay, what times what should multiply to get x squared? Well, x times x. I'm going to put an x in the first slot, x in the second slot. And then we have to ask the question, what 2 numbers multiply to give 2 and add to give 3? Multiply to give 2 and add to give 3. Well, positive 2 and positive 1 do the trick, right? Positive 2 times positive 1 is positive 2. Positive 2 plus positive 1 is positive 3. So what I've done, I've factored the polynomial on the left-hand side, x squared plus 3x plus 2, into x plus 2, x plus 1. Now there's something really important here we need to make a note of. It's called the zero factor property. This is a property of numbers that says if a times b equals 0, then either a is 0 or b is 0. One of them has to be 0. So we're going to apply that property here to the equation we have with the 2 factors. So according to the zero product property, we have x plus 2 times x plus 1 is 0. So that means your first factor must be 0, or your second factor must be 0. So I said x plus 2 equal to 0, or x plus 1 equal to 0. So what we've done, we've reduced this equation into 2 small basic equations. So to solve the first one, I'm going to subtract 2 from each side, and I'm going to get x equals negative 2. Or for the second one, I'm going to subtract 1 from both sides. I'm going to get x equals negative 1. So you have 2 solutions here. If I were to plug in negative 2, it would work. Or if I were to plug in negative 1, it would work. So 2 solutions, negative 2, also negative 1. All right. So factoring is a really useful technique for solving quadratic equations if you can factor. How about we have another situation? How about y squared minus 2y equals 48? So notice that this one is not a power equation situation, right? It's not y to a power equals a number. And the reason you can't make this into a power equation is because it has that y term there. So because it's not a power equation, what we want to do, we want to get into the form of a quadratic where you get 0 on one side. So this is a quadratic equation, but it's not in the standard form where you have 0 on one side. So we want to get 0 on one side. So what we're going to do, we're going to get rid of that 48 on the right side. We're going to subtract 48 from both sides. That's going to give me y squared minus 2y minus 48, and then equals 48 minus 48 on the right is going to give me 0. So I want 0 on one side. That's what you do for these when you cannot use the power equation form. Okay, so now we want to factor the left-hand side. I'm going to make 2 pairs of parentheses. And remember, this is all equal to 0 now. So I'm going to put a y in the first parentheses and a y in the second parentheses, y times y to get y squared. And I got to find 2 numbers that multiply to get negative 48, right? And add to get this middle number here, negative 2. So what 2 numbers do that? Well, negative 8 and positive 6, right? Negative 8 and positive 6. Multiply to give me negative 48 and add to give negative 2. All right, so I got my two factors. Now, according to the zero factor property, I set those equal to 0. Right, I got something times something equal to 0, so either the first one's 0 or the second one's 0. So in the first one, I'll add an 8 to both sides to get y by itself. I'll get y equals 8. On the second one, I'm going to subtract a 6 from both sides. I'll get y equals negative 6. So there I have two solutions. Either one will work. So if I were to plug in 8, it would work out. If I were to plug in negative 6, it would work out now. This is circle's not looking good. Okay, there we go. Two solutions. All right, how about a number 3? Number 3. How about a z squared equals 5z plus 50. So that's a quadratic, right? The largest power is power 2. But it's not a power equation, right? That 5z there, that 5z keeps it from being a power equation. Remember, power equations, in this case, would be like z to a power equals a number. Well, we got the 5z, so it can't be a power equation. So that means this is a quadratic. It's not a power equation, so we want to get 0 on one side. Let's get 0 on the right side. 0 on the right side. So I'm going to subtract 5z and 50 from both sides. So subtract 5z and 50 from both sides. So on the left-hand side, I'll get z squared minus 5z minus 50. And on the right side, the 5z and the minus 5z and the 50 and the minus 50 will cancel and just get a big 0. All right, so I got this in the standard form. This is the standard form for a quadratic. Now I'm going to factor. Remember, it's all equal to 0. So we're going to do a z in the first parentheses, z in the second parentheses, z times z to get z squared. And now we got to find two numbers that multiply to give negative 50 and add to give what? Minus 5. So if I think about two numbers, I can say negative 10 and positive 5 will do the trick, right? Negative 10 times positive 5 is negative 50. Negative 10 plus positive 5 is negative 5. So I factored and then I set my factors equal to 0. Z minus 10 equal to 0. Z plus 5 equal to 0. So we've broken this into two small basic equations. In the first one, I just add 10 to both sides. Get z equals 10. And the second one, I subtract 5 from both sides. And I get z is negative 5. So, two solutions there, 10, negative 5. All right, let's do a number 4. Shall we do a number 4? What if I had x squared equals 20x? X squared equals 20x. Well, this is definitely not a power equation. You can't get x to a power equals a number here because you got that x term. So remember your procedure when you have a quadratic that's not a power equation, get 0 on one side. So let's get 0 on the right side. I'm going to subtract 20x from both sides. It's going to give me on the left x squared minus 20x. And on the right, 20x minus 20x is 0. Now, how do you factor one of these guys without a constant? You got an x term, you have an x squared term, but you don't have a constant. Well, you can still factor. If you look closely here, notice that x squared and 20x have something in common. They have an x. So you can pull out an x and then write a parentheses and ask the question, what times x gives you x squared? Well, x. And then what times x gives you negative 20x? Well, negative 20. So your factors are x and x minus 20. And remember, that's all equal to 0. So when you have something times something equal to 0, one of them has to be 0, so set x equal to 0, the first factor. Or x minus 20 has to be 0, so set the second factor equal to 0. So I got one of my solutions already. The other one, x minus 20 equals 0, I can add 20 to both sides. And that's just going to give me x equals 20 for the other solution. So I got two solutions. If I plug in 0, this equation will be true. If I plug in 20, this equation will be true. Either one of these works. All right, so that's a little different, that type of problem. It's actually quite easy, though. Let's do number 5. Number 5. How about? Is this number 5? Let me count. Ooh, I miscounted. I got my numbers mixed up. This should be a number 3. Should be a number 4. This should be a number 5, and the one we're starting, should be a number 6. Okay, I miscounted. What if I were to have 5x squared plus 6x plus 1 equals 0? Okay, so this is already in the quadratic standard form, the standard quadratic form. So we would want to factor the left-hand side, but notice this is one of those where you got a number in front of the x squared term. So we factored these back in section, I believe, 1.5. To remember how it goes, you're going to make 2 pairs of parentheses. Remember, this is all equal to 0. So since there's a number in front here, 5, we're going to put a 5x in the first parentheses, of 5x in the second parentheses. And then we have to find 2 numbers that multiply. Let me do this in green, maybe. Multiply to give 5 times 1, which is 5. You got to find 2 numbers that multiply to give 5. And that add to give this middle number here of 6. So what 2 numbers multiply to give 5? 5 times 1, 5. And add to give 6. Well, 1 and 5. So I'll put a plus 1 here and a plus 5 here, right? 1 times 5 is 5. 1 plus 5 is 6. Now, you're not done in this type of factoring. You still have to divide out anything in common within each factor. So I look at the first factor where there's 5x and 1, nothing in common. But the second factor, 5x and 5, I have to divide out a 5 here that's in common. So that's going to leave me the following factors. 5x plus 1, which hasn't been touched. And what happens here? Well, the 5's cancel and you get x plus, 5 over 5 is 1, x plus 1. So 5x plus 1 and x plus 1 are actually your factors. So then what you'll do, you'll set these equal to 0. 5x plus 1 equals 0. And the other one, x plus 1 equals 0. And you'll solve those 2 individual basic equations. The first one requires subtracting a 1 from both sides. So you get 5x equals negative 1. And then you'll divide both sides by 5. And that'll give you x equals negative 1/5. That's one of your solutions. The other one, you're just going to subtract 1 from both sides, and you get x equals negative 1. So the 2 solutions here would be negative 1/5 and negative 1. Let me just do one more like that. Just one more example, so you have enough in your catalog of examples. So number 7, this will be, let's make this the last problem. 3x squared plus 5x equals 2. So this looks like a quadratic because the largest power is 2, but it's not in standard form, right? So you need to get 0 on the right side. So let's subtract a 2 from each side. So we'll have what? 3x squared plus 5x minus 2 equals 0. So we have it in standard form. Now we got to factor. It's not an easy factoring problem. And this is all equal to 0. It's not easy factoring because you got that 3 in front of the x squared. So how we're going to start the factoring, we're going to put 3x and 3x in each parentheses. And then we got to find two numbers that multiply to give 3 times negative 2, which is negative 6. So find two numbers that multiply to give negative 6, and add to give the middle number here, the middle number being positive 5. Can you find such numbers? Multiply to give negative 6, and add to give 5. How about 6 times negative, 6 and negative 1? 6 and negative 1. 6 times negative 1 is negative 6, and 6 plus negative 1 is 5. So I'm going to put plus 6 here in the first parentheses after the 3x, and minus 1 here in the second parentheses after the 3x, right? 6 times negative 1 is negative 6. 6 plus negative 1 is 5. Now, I would be done, but wait, we're not done, right? You have to remember to divide out anything in common between your factors. So look at the first factor. Notice the first factor, you got 3x and 6. There's a 3 in common that we're going to divide out. So when we divide out that, 3's cancel. And we're going to have what? X plus 6 over 3 is 2. So we got x plus 2 as our first factor. Our second factor, there's nothing to divide out between 3x and 1. So we're just going to keep it as 3x minus 1. So you got x plus 2 times 3x minus 1 equals 0. Set your factors equal to 0. So the first one, x plus 2 gets set equal to 0. The second one, 3x minus 1 gets set equal to 0. And then you solve those. Oops, I didn't set the first one equal to 0. The first one, we're going to subtract the 2 on each side, and we're going to get x equals negative 2. We're done with that one. The second one, you're going to add 1 to both sides. And you're going to have 3x equals 1, and then just divide both sides by 3 to get the x by itself. That'll give us x equals 1 over 3. So there are your two solutions. Negative 2 works, or 1/3 will work if you plug them in. All right, so that's it for this video. In the next video, we'll look at other types of quadratic equations, maybe that you can't solve by factoring.